Hello and welcome to Maths with Udom. I still remain your online mathematics tutor, Mr. Okon Udom. Today, we are going to look at another topic in mathematics, which is addition of fractions with different denominators. Addition of fractions with different denominators. Okay, so let's start. Addition of fractions with different denominators. Okay, addition of fractions with different what? Denominators. Okay, now addition of fraction with different denominators. For us to solve this kind of problem, the approach is that we look for the LCM of the denominators and we use the LCM to simplify the given fractions. Okay, and that is how to go about solving problems under this topic. So let's have some examples. Are we together? So we are to simplify these fractions. What do we mean by simplifying fractions? It means reducing the fractions to the barest minimum. Okay, that is breaking the fraction down to the barest minimum, making it smaller until you cannot what? Reduce it again to the barest minimum. Okay, so let's simplify the following fractions. The first one there, let's get this underlined. Okay, simplify these fractions. Number 1. Five over 6 plus 3 over 8. Number 2, 3 over 4 plus what? 2 over 3. Are we together? Number 3, 5 over 6 plus 2 over 9. Number 4, 1 over 4 plus 3 over what? Over 5. And lastly, number 5, 7 over 8 plus 4. Okay, so let's quickly run through the solution. So if you look at all these fractions, they all have different denominators. Okay, so let's start solving. Solution for number 1. What do you have in number 1? 5 over 6 plus what? 3 over 8. Okay, so we are going to look for the LCM. After then, we continue. So let's find the LCM of the denominator 6 and 8. So let's do it in this corner. 6 and 8. So what can go through? 2 here. 2 can go in 6 and 8. So how many 2 can go? We are looking for the LCM. How many 2 in 6? 3. 2 in 8? 4. What can go again? 2. 2 cannot go in 3. You repeat it. 2 in 4. 2. 2 can go again. 2 in 3? Impossible. 2 in 2? 1. Then 3 can go. 3 in 3? 1. And then 1. So what will be our LCM? Okay, we circle all the what? The prime numbers outside the box. So our LCM, which means lowest common multiple, is equal to what? 2 multiplied by 2 multiplied by 2 multiplied by 3. So we have 2 times 2 times 2 times 3. Are we together? So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So our LCM is 24. So what do we do with the LCM? Then we come here and write equals to 20 what? 24. Okay? Now, how many 6 can go in 24? 4. So you write 4 times our what? Numerator. What's our numerator? 5. Plus, how many 8 can go in? Okay, let me space the work so that it will be clearer. Our LCM is what? 24. How many 6 can go in 24? Okay, 4. 4 times our numerator 5. Plus, how many 8 can go in 24? 3. 3 times our numerator what? 3. Okay? So let's clean this side. Okay? Let's continue. So we have 4 times 5 is what? 20. Plus numerator 3 times 3 is what? 9. Everything divided by what? Our denominator 24. Okay, are we together? So from here, what do we have? We have, let's add the numerators together. If you add the numerators together, 20 plus 9 will give us 29. Divided by what? Our denominator. So this is an improper fraction. So what do? We convert it into a mixed fraction. Okay? So let's go. How many 24 can go in 29? I say 24 go in 29. How many times? Once. What is remaining? If you remove 24 from 29, it will remain 5. Okay? Then 5 divided by what? Our denominator 24. So that is how to solve such problem. Is that okay? Let's move to number 2 quickly. Number 2. Remember how we started from? We first find the LCM of what? Of the denominators. After that, use it to simplify the fraction. So number 2, we have 3 divided by 4 plus 2 divided by 3. Okay? So the LCM of 4 and 3 is the first thing we are going to look for. So let's work it here. 4 and 3. Let's find the LCM. What can go? The prime factor. 2. 2 in 4, 2. 2 in 3, repeat it, impossible. 2 can go again. 2 in 2, 1. 2 in 3, impossible. Then 3 can go this time. 3 in 1, repeat 1. 3 in 3, 1. So what do? We circle the ring outside and multiply them to get our what? Our LCM. So what do we have? So LCM is what? 2 times 2 times 3. 2 times 2 times 3. So what do? We multiply them together. So 2 times 2 is 4. Why 4 times 3 is what? Is 12. Okay? So what do we do with it? We come back here and write our division line. We place 12 under that. So how many 4? 4 from the denominator. How many 4 from the denominator can go in 12? 4 in 12 is 3. So 3 times our numerator 3. Plus, because we are using positive, plus 3 in 4. 3 in 12 is what? Is 4. 4 multiplied by our numerator what? 2. Okay? So let's move to the next page and get the final answer. So from here, our numerator 3 times 3 is what? Is 9. Plus 4 times 2 is what? 8. Okay? Divided by what? Our denominator 12. So we add 9 plus 8. What is 9 plus 8? It will give us 17. 17 divided by what? 12. This is an improper fraction. So we change it to a mixed fraction. So how many 12 can go in 17? 17 once. What is remaining? It will remain 5. 5 over 12. And that is our answer in mixed fraction. Is that okay? So let's move to example 3 quickly. Example 3. You can see how interesting and simple they are. You follow it step by step, and then you get your answer. Maths is fun. Okay? Example 3. What are we asked to do? We have 5/6 plus 2 divided by 9. Let's find the LCM of our denominator 6 and 9 in this corner. 6 and 9. Okay? What prime number can go? 2. 2 in 6, 3. 2 in 9, impossible. You repeat it. 3 can go this time. 3 in 3 is what? Is 1. 3 in 9 is 3. Then 3. 3 in 1, 1. 3 in 3, 1. So what will be our LCM? Okay, as you have done before, you circle the prime numbers outside and then we multiply through. So our LCM will now be 2 times 3 times 3. So 2 times 3 times 3. Let's multiply. 2 times 3, 6. Why 6 times 3 is what? 18. Then you come here with that LCM, write your division line, draw your division line, put 18 under the division line. Now, what do we do with it? We now come here and say, how many 6 can go in 18? 3. 3 times our numerator 5. Plus. Okay. How many 9 can go in 18? 2. 2 times our numerator 2. Then we'll come to this side and finish it up. So our numerator, 3 times 5 is 15. Plus 2 times 2 is what? 4. Everything divided by what? Our denominator 18. So let's add the numerator. 15 plus 4 will give us 19. Divided by what? 18. You can't leave the answer this way because it's an improper fraction. So how many 18 can go in 19? 1. Remember 1 over what? 18. So that is our final answer in what? In mixed fractions. In mixed fractions. Example 4. So what do we have in example 4? We have 1 over 4 plus 3 over what? Over 5. So the first thing is to find the LCM of the denominators what? 4 and 5. Let's first find the LCM of denominator 4 and 5. Okay, in that corner. 4 and 5. So 2 can go. 2 in 4 is 2. 2 in 5, impossible. You repeat that. 2 again. 2 in 2, 1. 2 in 5, impossible. Repeat 5. Then 5 can go. 5 in 1, 1. 5 in 5, 1. So what do? We circle our prime numbers outside, our prime factors. Okay? So our LCM will now be, we multiply the numbers outside together. That will be 2 times 2 times 5. 2 times 2 times 5. So 2 times 2 is 4. 4 times 5 is what? 20. So our LCM 20, we bring it back here. Draw your division line. Put 20 under it. How many 4? How many 4 can go in 20? 5. 5 times our numerator 1. Plus. How many 5 can go in 20? 4. 4 times our numerator 3. Okay? Then come to this side and finish it up. Okay? So let's add the numerator. 5 times 1 is 5. Plus 4 times 3 is 12. Over our denominator what? 20. So that gives us, let's add the numerator. 5 plus 12 will give us 17. Divided by what? 20. So this one is a proper fraction. And as you can see, it cannot be simplified further. So we leave the answer the way it is. Okay? So that's our answer for number 4. Then number 5. Okay? So what do we have in number 5? We have to simplify 7 over 8 plus a whole number 4. So this one is a special case. Any whole number, all the whole numbers, they have 1 as their denominator. So we put over 1 here. Is that okay? So what is the LCM of 8 and 1? You see 8. So we come here and write 8 as our what? Denominator. How many 8 can go in 8? 1. So 1 times our numerator 7 plus how many 1 can go in 8? 8. 8 times 4 will give us what? 32. So let's do it accordingly. 1 in 8 is 8 times 4. So let's move on. So let's multiply the numerators. 1 times 7 is 7 plus 8 times 4 is what? 32. Everything divided by what? Denominator what? 8. So the next thing, we add our what? Numerators together. So 7 plus 32 will give us what? 39. Okay? So 39 divided by what? 8. So we'll come here and say, okay, how many 8? This is an improper fraction, so we cannot leave our answer this way. Okay? So what do? We change this to improper fraction. So how many 8s can go in 39? That will be what? That will be 4. Okay? Because 8 times 5 is 40. So 8 times 4 is 32. Okay? So that will be 4. 4 whole number. 32. So subtract 32 from 39. That will give us 7. That will be 7 divided by what? 8. Okay? So that is how to solve this problem. Okay? 8 in 39 will give us what? 4. Okay? So 32. Subtract 32 from 39. You will get 7. Is that okay? Divided by what? Our denominator 8. So you have converted this improper fraction into what? A mixed fraction. Is that okay? So assignment quickly. Let's take our assignments. Let's take our assignment. So what's our assignment? Let's get it underlined. So assignment, simplify the following fractions. Okay? Simplify the following fractions. So what are the fractions? Number 1, we have 8 over 15 plus 2 over 3. Number 2, what do we have? 5 over 9 plus 2 over 3. Number 3, we have 3 over 4 plus 5 over what? 24. And lastly, number 4, we have 2 over 3 plus what? 4 over 27. So these are your assignments. So we have come to the end of today's class. Okay, I want to believe you enjoyed today's class, and it's very, very educative and simplified. And I believe you understand everything. So keep on practicing. Is that okay? So we have come to the end of today's class. But before you go, kindly like this video. Drop your comment in the comment section on how to serve you better. Share this video to all your friends and family members all over the world. And most importantly, click on the subscribe button. Remember, The best way to become a mathematician is by constant practice. Keep on practicing every day until I come your way again next time. I still remain your online mathematics tutor, mathematician Okon Udom, and I'm saying to you, remain mathematically sound. See you in my next class. Bye for now.